What is going on, guys? Welcome back. We're going to do another video full of Codewars challenges where I show you my full thought process, unedited, unfiltered. So let us get right into it. Alright, so we're going to do another Codewars session today. The rules are the same as always. I'm not allowed to use ChatGPT or any other large language model. I am allowed to use Google, but only for very small specific things like how to flatten a list in Python, how to iterate over something efficiently, what does this function do, and so on. Not the exact solution to the problem, obviously. So if it's an algorithmic problem, I'm not allowed to Google the solution to this algorithmic problem. I'm allowed to Google things like individual functions. I'm allowed to look up documentation, Stack Overflow, about basic stuff, and so on. And I'm not going to edit out any mistakes. So I'm not going to edit out any failures. I'm going to show you how I fail. If I fail, I'm going to show you all the wrong approaches. I'm only going to edit something out if it's silence for like 5 minutes or anything that's similar to that. But I'm going to show you my full thought process. And it has happened multiple times that I was not able to solve a problem. So this will also be part of the video if it happens. Now, my goal is to start with 6Q. But I think we can also try something harder. For example, we can try this 4Q, or at least we can look at it. But I don't want to spend too much time on just one single issue. So let's start with a simple 6Q challenge for warm-up, hopefully for warm-up. And then we can maybe sort by popularity. Now I have done this one, this one, this one. What is the first one that I have not done here? This one. Is there a reason for that? Probably the description was too long. No. You're given an array which will have a... Oh, actually it says train again, so we cannot do this one. Duplicate encoder. Take a 10 minutes walk. Let's see. You live in the city of Cartesia, where all roads are laid out in a perfect grid. You arrived 10 minutes too early to an appointment, so you decided to take the opportunity to go for a short walk. The city provides its citizens with a walk-generating app on their phones. Every time you press the button, it sends you an array of one-letter strings representing directions to walk: north, south, west, east. You always walk only a single block for each letter, and you know it takes you 1 minute to traverse one city block. So create a function that will return true if the walk the app gives you will take you exactly 10 minutes. You don't want to be early or late, and will, of course, return you to your starting point. Return false otherwise. So I'm not sure I understand this properly. We just get... Let me just go to desktop. I have a folder here called Codewars. Remove everything in that folder. I think it's a... Do we have anything in that folder? No. Okay. Let's open up a main Python file. I do have a swap file, however. Okay. And here now what we're going to do is we're going to brainstorm this. So basically the idea is we have a perfect grid and we have the opportunity to take a short walk for 10 minutes. And we basically get direction instructions, so basically up, down, left, right. And our goal is to see if it takes us exactly 10 minutes and if it returns us to the starting point. Okay. And there are no obstacles. So basically every left cancels every right, every up cancels every down, and that's basically it, right? So I would get something like, let's actually do it and see if we can figure it out. I think this is not too difficult. So we get a list, and the list should, what exactly takes 1 minute? Only a single block. And you know it takes 1 minute to traverse one city block. Okay, so basically the list length, shouldn't the list length always be 10? Isn't that... Not sure if I'm misunderstanding that. It doesn't sound too difficult to me. So what is the input? We get some input and should return false if walk is too long. Okay, but doesn't this just mean that I have to return if length of walk? Let me just open this up here. Actually, let me enable the Vim mode first. So if length of the walk is not equal to 10, I don't know if I misunderstood this, but shouldn't this always be false? So now by doing that, I should at least sometimes get the correct answer. Yeah. Okay. Makes sense. I think this is what we have to do here. So basically, we want to have exactly 10 instructions, and the 10 instructions should cancel each other out. So doesn't this just mean that we can say if the number, so if the walk.count of n is not equal to walk.count of s, return false, and if walk.count east is not equal to walk.count west, that should also return false. And then actually, yeah, if none of this happens, then return true, I guess. Isn't this basically what it boils down to? Or am I thinking about this? Okay, wow. That's it? Okay, let's see if that solves the problem. Okay, this was really not that difficult. Yeah, so basically the idea is you get the instructions. You are allowed to have exactly 10 instructions because one instruction takes 1 minute. We have 10 instructions, exactly 10 minutes. And then basically every time you go up, you have to also go down to end up where you started. And if you go left, you have to go right at some point and vice versa. So you want to have the same number of ups as downs and the same number of lefts as rights. And that's basically it. So yeah, okay, this was easy. Let's see what the other solutions are. Maybe there is a one-liner or something. I mean, yeah, okay. It's basically the same thing that I did as a one-liner, which is not necessarily always the best thing to do. But yeah, this is kind of too much. You don't need to do all of this. But yeah. Great. So this was quite easy. Let's try something else. Let's go for another 6Q. And then maybe we go to a, or actually I wanted to look at this one. What does it do? Given an array of x positive integers, now this is 4Q, probably I'm not going to do it because it's probably too long for this video or I'm going to fail. Given an array x of positive integers, its elements are to be transformed by running the following operation on them as many times as required. If x at position I is greater than x at position j, then I should be I minus j. When no more transformation are possible, return its sum, smallest possible sum. So 6 is greater than 9, no, but 9 is greater than 6. So, or actually 21 is greater than 9, so we subtract. Okay, but I'm not sure right now if I have to find some efficient solution for this or if it's actually just doing exactly what's written here. Because isn't this the instruction for the full code? Isn't this just perform this operation until no more transformations are possible? Yeah, I'm not sure I understand this, but I want to do a 6Q first, so maybe we can do this later on. I'm going to go again for 6Q. I'm going to sort again by popularity. And we're going to see what kind of challenges we have here that I haven't solved yet. So replace with alphabet position. I mean, this is super simple here. I think 6Q might be a little bit too... I'm not sure if last time... Wasn't it a 6Q challenge that I failed last time? It seemed to be a little bit more difficult, but maybe this was just a more difficult challenge last time. But, I mean, what is that? Convert a string to camel case. I mean... Yeah, this is actually quite simple. We can do that as a warm-up, but what is this one here? In this kata, you're required to, given a string, replace every letter with its position in the alphabet. If anything in the text isn't a letter, ignore it and don't return it. Okay. Well, I mean, sure. That's kind of, yeah, let's do that, and then we can move on to 5Q, because it seems like 6Q should actually be quite easy, even though it wasn't the case last time. So I would say import string dot, or actually import string, and then we can say, that we have alphabet is equal to string dot, what was the function? Let me just see here in my Python command line. Import string. Was it string dot ASCII? No, string dot letters. No, what was it? String ASCII Python. ASCII letters. I think that's it, right? So string ASCII letters. Okay, actually we only need lowercase for what I'm trying to do. Yeah, so we're gonna go and say string ASCII lowercase, and then we're gonna say that we want to have a white space, join, and a list comprehension where we're gonna say character, or actually we're gonna say alphabet, index of the character, lower for character in text if character in alphabet. And return that. Shouldn't that already work? No, okay. What's the problem? We have unexpected exception. Expected string instance. Oh, first of all, I probably also spotted a second mistake, but we of course need to turn this into a string. But also I think we will have to add +1 to this. But then I think it should work. No. Okay, so 8, 5, 19 should equal 28, 5. Oh, okay. Because we need to do C lower here as well. There you go. Okay, so to explain the solution, we basically take the alphabet. It's a string of A, B, C, and so on up until Z. And what we do is we say, okay, if that character, lowercase, if the character in lowercase is part of the alphabet, get the position in the alphabet, get the index at 1, because index starts at 0, +1 is 1. So we start at 1, and we turn that into a string, and we concatenate all of these separated by white spaces into a final string. Yeah, that's quite easy. So let's go and submit that. And let's see if someone else has the solution without string and without a static alphabet. Oh, this is actually interesting. Okay, he takes the ordinal of the numbers, so basically the ASCII code minus 96, which makes sense. And yeah, okay, this is cool. I like this. But he also uses lower. Okay, this is a nice solution. All right, so let us move on to something more complex. Let's go to, where is my filter here? Let's go to 5Q and sort by popularity. I think the problem is last time I sorted by newest, and I think the most popular ones are going to be the average or the probably easier ones of the categories. So if I go for 5Q and sort by popularity, we will probably find some pretty easy 5Q challenges. Calculating with functions, maximum subarray sum, Pete the baker, product of consecutive Fibonacci numbers. These are the Fibonacci numbers. Okay, yeah. Given a number, say for product, we search 2 Fibonacci numbers. Oh, okay, that's interesting. Now I can of course do the brute force solution, but the question is, we're basically looking for 2 Fibonacci numbers that when you add or when you multiply them together, you get a resulting, you get the number that's the result. I'm thinking right now if I even have a starting point other than just trying. I mean, what we could do is we could try to find out. Well, we could try to find all the numbers that are. Actually, how could we do that? Not sure. I mean, we could do a brute force approach. I'm not sure if that's reasonable. Your function takes an integer and returns an array, which gives us. Oh, they have to be consecutive. Okay, so they're not just any Fibonacci numbers. They have to be two consecutive numbers, so n and n plus 1. And then it gives us these two numbers, or it gives us this, or it gives us that if it's possible. And if we don't find two consecutive numbers, we return what exactly? False. But why do I return fn and fn plus 1? I don't really understand that. Fn being the smallest one, such as... Okay. I mean, we can try that. I'm not sure if I'm going to be able to do that here while recording, because every time I record a video, my IQ drops by around 15 points. So yeah, let's see. We get a number. I'm gonna go into my terminal again here to play around a little bit with that. I'm gonna go to desktop, Codewars, and we're gonna open up the main PY. So basically I have Fibonacci numbers. And it makes sense probably to have a bunch of them pre-calculated. I'm not sure if that's part of the... I'm not sure if that's fair, but to make things more efficient, probably it makes sense to have them already in an array, the first, I don't know, 20 numbers or something. But let's go and define a function Fibonacci n, which is not going to be recursive. We're going to do this iteratively. So we're going to say that let's say for I in range, so let's say number, or let's say A and B are 0 and 1, and then say for I in range n, do A equals, or AB equals B and A plus B, and then return B, I guess, right? So not sure if this is correct. So if I say print Fibonacci 1, I mean, how is it defined actually? So I need to have the same definition here as this task has. So f of 8 is 21. Okay, so f of 8 is 21. Is it also 21 in my case? What's the problem here with this deleted? There you go. So f of 8 is 34, so I should actually return A. Yeah, okay. So this is my implementation of Fibonacci, and then basically I have to find numbers that when you multiply them, they result in product. I mean, wouldn't this just be... Yeah, I mean, the brute force would be to just pick any... So let's see, what is the function called? Product fib. So let's say product fib given some prod. And we're gonna say now for n in, or actually done equals false, while not done, n equals 1. And I think we start with 1, right? So we don't have Fibonacci of 0, I think. Yeah. Okay, so while not done, we're gonna say that we want to multiply So we're going to say if Fibonacci of n plus Fibonacci of n plus 1, or actually times, sorry, if that is equal to the product, then we return, what was it? We return the two values. So we return Fibonacci n. Actually, probably we should go and Fib n is going to be Fib n plus, let's see, n1 is going to be equal to Fib n plus 1. And then we can say if Fib n times Fib n 1 is equal to the product, then we can return Fib n and Fib n1 and true. Otherwise, if it's not the case, we want to check if that is already above. So yeah, we basically want to do if Fibonacci n times Fibonacci n1 is larger than the product, we need to return Fib n2 and false. Yeah. I mean, one of the two is going to happen, so we don't even need a break or a... I mean, we can go with a while true here, I think. The only thing that we need to consider is that we need to increase n every time. Yeah, so wouldn't this be what we're looking for? So if I call this on, what is an example? 714 is given as an example here. So let's call product fib of 714. Wouldn't that be what I'm looking for? Yes, okay. And then we have 800. And this should return, oh, actually it was n1. Yeah, okay. I mean, it seems to work. So I'm just gonna take this. Actually, I have to yank it into my clipboard. Then I can replace this. Now what I'm gonna change here is I'm gonna remove this. And I think I'm going to cache this. Now I don't know if cache decorator Python. I mean, we do have functools LRU cache, which I'm gonna use. Yeah, why not? To optimize for performance. But before we do that, let's see if it actually works in the first place. So let's go and try to test. It works. Now to make this faster, or do I even have to make this faster? Let's just go and see if it works. Okay, this one is false. Everything worked except for this one test. And this is probably when you input 0, right? Or not? I mean, it has to be 0 where it fails. No, actually for 0 I get 1, 1 false. I think it's probably for... Oh, sorry. It's probably for negative numbers. I don't know. No, actually I do get 1, 1 false, but it should be 0, 1. Okay, okay. So I think the only difference here is I have to start at 0. And then it should find... Yeah, okay, so basically changing that to 0 should work. Attempt. There you go. Okay, so this was also not too difficult. Yeah, to optimize for speed, it would probably be useful to cache this so that we don't have to constantly recompute the Fibonacci numbers, because we're probably going to do that for a lot of similar numbers all the time. but it doesn't seem to be important in terms of, yeah, it doesn't seem to be relevant here. So let's see if we have some one-liners. It's always interesting to see how people can condense it into very little code. This is basically... Okay, yeah. This is actually very, very concise. This is nice. So he combined the Fibonacci and the product Fibonacci function into one. He basically does the same thing, start at 0, 1. And while the product is still larger than the product, so while the past product is larger than the product of the two numbers, increase, go to the next number, and once you have it, just go and return the list. If it's the same or not is going to be the Boolean here. Yeah, that's quite elegant, actually. I like this. Okay, so today we seem to be more competent than last time. So let's go to another 5Q challenge. Let's go to something like number of trailing zeros of n. Oh, this sounds like work. Okay, this is kind of cool. Now the question is, I mean, I want to attempt it just to see if it's easy or not, because one very easy thing to do is you calculate it, but then, no, the problem is that's not easy at all, because you cannot, I mean, this is like 6 factorial, right? 30 factorial. So this means whatever this number is factorial. This is huge. This is not something that you can just compute, because I'm pretty sure that if I open up Python and I type import math.factorial, I mean, if you just go with something like 52, that's already huge. If I go with something like 1,000, this is huge. If I go with 10,000, that is exceeding the limit, so we cannot calculate that actually. So there needs to be a pattern, and I'm not sure if I can find it now while recording and thinking about it. Let me think about this. I mean, it could be... I mean, how do you get zeros? You get zeros by getting tens. So you could get all the tens, all the hundreds, and all the products that result in tens. But then, you know, you could get something like... I'm not sure if I'm not talking nonsense right now, but 10 is divisible by 2, divisible by 5. I'm not sure if that makes sense, though. So let me just check that. I'm gonna play around with this a little bit, and maybe we're going to we're not necessarily going to finish this, but let's go into Codewars. Let's open up the main py file. Let's delete everything here, and let's just see what happens if I import math and I say print math factorial, and I want to do that for 5. I want to do that for a couple of numbers now. I want to do that for 5, for 6, for 7, for 8, for 9, and for 10, and also for 11. I want to see if that has something to do with what I'm expecting. So Python main py. 5, 6. Yeah, this makes a lot of sense. So isn't it just how many 5s and 2s you have and how many 10s you have? I mean, we have 1 0 here because we have 5 and 2. Then we have still 1 because we only have 1, 5, and 2. But how do you even formulate that? So my suspicion would be that the next time you get an additional 0, I'm not sure now if this is true or not. Let me just actually, let's print the number here as well. So let's print 5 and math factorial 5, and then let's do the same thing here for 6, 7, 8, 9. Actually, we can use Control A in Vim. let's do the same thing here. Oh, now I stopped. Let's go, let's go. It's a bit tedious now. But my suspicion is, I know I could just do a full loop, but I don't want to. So my suspicion is that you have to have 5s and 2s and 10s, because these are going to produce zeros. So if you have, I'm not sure if this makes sense, but I think the next, actually now I'm going to do the loop, so this was a waste of time now, but I think that the next 0 for I in range, let's go for 120. We're gonna print I and math factorial. I, which I think is not a very intelligent idea, because now I'm gonna get a lot of output. Okay, no, this was not what I was expecting. Or was it? So a 5 and a 2 produce 1 0 in my head right now. A 10 produces another 0. The next thing that produces a 0, I know it's probably, no, actually, no, we need to, because 15 and 2 also produces 30, which is a 0. So I don't even know how to approach this. And that's the problem now, because if I sit here and calmly think about this for a while, maybe I come up with a solution, but I don't want to do that now. So I actually try to find some quick fix. And if I don't find it, I have to either stop working on this problem or I have to Google something. But maybe we can find a pattern. Maybe we can just print here the number of zeros, which is going to be, I mean, we can take the logarithm, right? But, I mean, logarithm base 10. Isn't logarithm base 10? Let me just see. Import math. If I say math, logarithm, or actually log is the natural logarithm, isn't it? Let's see what happens if I do log 100. No, okay. Python log base 10. Okay, it's a log 10 function. So basically, if I do log 10 of 100, I get 2. But I don't think that I could do math dot factorial on a very large number like 10,000. Or can I? Or can I? Oh, what I had was the printing limit. So what's actually the number? Because that might be more simple than I thought, even though I don't think that it will handle this number, to be honest. I really don't think so. Actually, I need to go into insert mode, and then I have to copy. So, okay, still doesn't work. How many zeros are these? So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we're a billion, basically. I don't think that this is going to work. I mean, if it works, we're done. Because then I can just take this number and round it down. But I don't think that it's going to work like that. I don't think so. No. No, this is not going to work. But we can use that at least for the pattern recognition here. So I can use that to say math log of this number. And then we can see we have, no, this also doesn't make a lot of sense. Okay, actually this was nonsense. I'm talking nonsense here. We should actually count the trailing zeros. How do we count the trailing zeros? It's how many times you can divide by 10 without getting any remainder. So how often is What's the largest? No. How do you put that into code? Not sure I understand this right now. So basically, if I have a number 1,000, then taking modulo 1,000 would give me 0, indicating it has 3 zeros. If I go 10,000, it will give me 1,000. But that's all. Yeah, actually, it doesn't make a lot of sense. I'm thinking about this right now. I mean, I could go from right to left and find the first non-zero. I'm not sure if I know how to even count the zeros efficiently. Now, of course, I can just go and do some string operations, but I want to do it not extremely stupidly. So how would I even extract the number of zeros that I have in a number? If I have something like, or let's go, I have something like this with zeros in between as well, and then I have 3 zeros in the end. How would I do that? I mean, just for the sake of playing around with this, I could define a function count trailing zeros. And I could say, give me a number. And then I could say, okay, while true, or max diff, or let's say number of zeros is going to be 0. And then we're going to say while true, if the number modulo modulo 10 to the power of number of zeros plus 1. If that is equal to 0, we set number of zeros plus 1. Otherwise, we return number of zeros. So it terminates. Wouldn't that be what we're looking for? Not sure. Yeah, kind of, right? Okay. Okay, is that really the pattern? Are you kidding me? Every 5 values, we get an additional 0. Is that it? That somehow is a bit suspicious, but let's go and try to find that. Is that really true? I struggle to believe that. But it could make sense. So yeah, it actually seems to be the case. So basically, wouldn't we do... Okay, let me just double check this here. Wouldn't this be the same thing as taking I, floor divided by 5? No. Or isn't this the whole pattern? I'm not sure. Let me analyze this again. I'm a bit confused now. So every 5 values, we get an additional 0, it seems. What happens at 100? All of a sudden, we get 2 zeros. Okay. And then again, 1 every 5. So we have to divide by 5. But we also need to add to it floor division by 10. Is that it? No, this is too much. I think what's the problem here? Let me try this again. No, so it's 1 additional 0 for every 5 values, but then also 1 0 for every 100 values. Is that true? Is that also true for higher values? No, it somehow still doesn't add up. Or actually, it's that times 2. No, it's still not correct. I'm not sure if okay, so let me just do this here again. These are the actual numbers. So we have 1 0 here. Then we get the second 5. We have 2 zeros, so up until this point, everything's fine. This floor divided by 5, 4. This floor divided by 5, 4. Okay. This floor divided by 5 is actually 10. So there's something in between here. Oh, we get a jump at... We get a jump here as well. From 49 to 50, we get a jump of 2. Why is that? Because it's a combination of 10 and 5. Is that roughly what I was talking about before? I'm not sure. Then we get 16. Oh, here again. 75. So that is 25 after 50. Did we also get a jump at 25? No. Oh, yeah, we did. Okay. We seem to get a jump when it's a multiple. No. It's a product of... I don't know how to put this into math. I don't think I have the full pattern yet. Because we do have... Where do we get the next jump? 75. So it's again 25. And then we get it again at... Maybe that's it. Every 25 values, we get a jump of 2. What about that? Does this make sense? Could that be it? Oh, what did I do now? Is it just 25? Oh. Is that the answer? Let's see. Return number floor divided by 5 plus number floor divided by 25 times 2. No. Because for 30, it should equal 7. But it does in my case, so what did I do wrong? Oh, actually it's not times 2, it's just that. Okay, but we have a problem with 1,000. So it's not as simple as that. And I assume it's because it's powers of 5. This is just my guess now. I have no reason to believe that other than spotting a pattern here. But the next power of 5 would be 125. So we should see the problem if we go to 130. There you go. Okay, so we add 1 for every power of 5. So we should be correct again if I do 125 here. There you go. Okay, that's a solution, I guess. I don't understand why, but how do we put this into code? We basically flow divide by all the powers of 5. Or is this the same? This is now just a guess. Is this the same as taking the logarithm base 5? Is this the same? I'm not sure. Log base 5. Python. So import math log 525. What is that? Is this? Okay, the second one is the base. All right. Okay, but isn't that... So if I have 127, I have to check up until 3 powers of 5, or 5 to the power of 3. So wouldn't that just be... yeah, I mean, one very simple way to do that now is to basically say... I'm going to do this in Codewars right away. There's probably a one-liner that's way more elegant, but what I think about doing right now is saying import math and saying for I in range math, or let's say math.floor math.log of number and 5 result is equal to 0, then result plus equals n floor division by 5 to the power of I. And it should start with 1. Do we have to do plus 1 here? I think so, right? And then return result. I'm not sure if that works, but in my head it makes sense right now. No. Yeah, we should check for if n is larger than 0. The problem is, what is the factorial of 0? Is it even defined? It's 1, right? So otherwise, return 1, I guess. Return 0. Okay, that's it. So to be honest, I don't really know why that's the case. I don't really know why we get an additional 0 for every 5th, every 25th, and every 125th, and so on number. It probably makes sense because we have, I don't know, there's probably some mathematical definition or mathematical analysis that we can do here, but I'm gonna just attempt to solve. It works, and now let's see what the one-liner is. And actually that's interesting. He explains it. He says, no factorial is going to have fewer zeros than the factorial of a smaller number. Each multiple of 5 adds a 0. Probably because of the 2, right? Not sure. So first we count how many multiples of 5 are smaller than n. This is exactly what I did. I did it with a logarithm, but you can also do it with a loop, I guess. Or we can also, yeah, you can also do it manually. Yeah, I mean, they're all basically doing similar things. I don't understand why exactly it works. Is it, I'm not sure, is it because of the 2? Because 2 times 5 is 10 and then we get a 10, but why don't we get it? I mean, yeah, because 10 is again just a 5. No, I don't know. To be honest, I really don't know why it's happening. My guess is it has to do with the multiplication, but right now, again, as I said, I'm recording, so I have minus 15 IQ points. Probably when I watch this video myself, I would understand it. But yeah, so I think we can stop here. I think this was a very successful session today. We did, I think, was it 2? Was it 3 or 4? I don't know. We did 3 or 4 katas, and we succeeded at them. So yeah. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.